Nice launch trajectory countdown. Pad is clear.
10, 9, 8.
Launch auto sequence has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Vehicle is supersonic. Stage separation confirmed. Dragon separation confirmed. Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
You're looking at a live view of Falcon Heavy on historic Launch Complex 39A at Kennedy Space Center, awaiting liftoff at 8:07 p.m. Eastern Time. Welcome to our live webcast of the USSF 52 mission, where SpaceX will launch the Space Force's X-37B Orbital Test Vehicle, or OTV, to space for its 7th overall mission to date. The OTV payload will conduct tests that include operating the reusable spaceplane in new orbital regimes, experimenting with future space domain awareness technologies, and investigating the radiation effects on materials provided by NASA. My name is Jesse Anderson, and I'm a manufacturing engineering manager here at SpaceX, and I'm excited to be here with you today, bringing you coverage of our 5th and final Falcon Heavy mission for the year, 9th overall since first taking flight in 2018, and 3rd Falcon Heavy launch in support of a national security space launch mission. And as 2023 comes to a close, today's mission also marks our 95th launch of the year, with our final mission expected to lift off from our neighboring pad in Florida in about 3 hours from now. And you can see both of those rockets there on your screen. A big thanks to all of our customers and the SpaceX team for a record-breaking year. Now, today's mission marks the 2nd time the X-37B orbital test vehicle will take flight on a SpaceX launch vehicle. Some of you may recall the first flight on Falcon 9 back in September of 2017, in which OTV-5 spent a record 780 days in orbit, breaking the vehicle's own endurance record. Here's a closer look at today's payload. For those of you following along, you'll know that we stood down from our initial launch attempt for this mission on Sunday, December 10th, due to bad weather. On our second attempt the following day, during the count, our teams reviewed data related to system checkouts, which resulted in a no-go condition and decision to stand down from launch that evening. We rolled the vehicle back to our hangar at Launch Complex 39A in Florida to be able to further assess data and address any issues. And during this time, the payload remained healthy and all systems are go for an on-time liftoff tonight. Weather is also looking great for today's T0. Today's flight will be on the Falcon Heavy that you see there on your screen. This is essentially 3 Falcon 9 rockets strapped together, which means that it can carry much larger payloads, not only to Earth orbit, but to the Moon and Mars as well. Like the Falcon 9, Falcon Heavy is a 2-stage launch vehicle. The big difference is that the Falcon Heavy first stage is comprised of 3 cores, and Falcon 9 has only 1. Falcon Heavy has 28 engines total. Each one of these cores has 9 M1D engines, making for a total of 27 engines across all 3 boosters, which you can see there on your screen. The 28th engine is a Merlin vacuum engine on the second stage and will power the payload to its separation orbit. Now, altogether, the Merlin 1D engines at the base of Falcon Heavy produce 5 million pounds of thrust, which is equal to 18 747s at takeoff. And in fact, the engines produce so much power that we don't run them all at full thrust all at once until after liftoff. About 2.5 minutes into flight, the two side boosters will separate from the center core and come back to Earth for near simultaneous landings at Landing Zone 1 and Landing Zone 2 at Cape Canaveral Space Force Station in Florida. This will be the 5th launch and landing of these Falcon Heavy side boosters, which previously supported USSF 44 and 67, Hughes Jupiter 3, and NASA's Psyche mission. Upon side booster separation, the center core will keep firing for about 90 seconds before shutting down its engines and then perform a standard stage separation from the second stage. We will not be attempting to land our center core today. For those of you looking closely, this is why you don't see any landing legs or grid fins on the center core. And moving towards the top of the vehicle, once the first and second stage separate, the second stage will propel our payload to its intended orbit. At our customer's request, we will not be showing views of Stage 2, so immediately after the Merlin vacuum engine on the second stage fires up, we'll be directing all of our attention to the landing of our side boosters. Now, above the second stage is where our payload is safely enclosed inside of the fairing. The fairing protects the payload from aerothermal loads, heating, and contamination during ascent. Once we reach the vacuum of space, we will jettison the fairing as the second stage continues on its journey to orbit. We will be attempting to recover the fairing halves today with our recovery vessel, Doug. And at T-minus 10 minutes and 8 seconds, the SpaceX team continues to count down towards our 8th operational Falcon Heavy launch and 9th overall since taking flight in a demonstration test flight back in February of 2018. All systems are a go. Before we began the webcast, the SpaceX launch director polled the members of the launch team and got a go for propellant loading and launch. And we are currently loading propellant on all 3 first stage boosters as well as the second stage. And you may be able to hear some of the live rocket sounds from our launch pad. Those pops and hissing sounds that you hear are from propellant loading, as well as the launch mount and strong back that the propellant is flowing through. Falcon Heavy uses 2 propellants. One is a refined form of kerosene called RP1, or Rocket Propellant 1. That's our fuel. The other is our oxidizer, which is liquid oxygen, or commonly called LOX. An oxidizer is a type of chemical that releases oxygen to mix with fuel and allows it to burn. Liquid oxygen is chilled well below its boiling point so that it has a much greater amount of mass per volume, which basically means that we can load more of it into the rocket. As a fun fact, the Saturn V first stage flown from this very pad on the moon missions also used liquid oxygen and kerosene. In addition to these 2 propellants, we also use the chemical TTEB, or triethyl aluminum and triethyl borane, as an ignition source. The combustion of RP1 and liquid oxygen is what makes the rocket go or fly, and it's the TTEB that sets the match to the propellant mix. Today's mission is for the U.S. Space Force and is being overseen by Space Systems Command, or SSC.
Center core RP1 load is complete.
Space Systems Command is the U.S. Space Force's field command responsible for acquiring and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and from space. For more on the SSC, let's take a listen.
The ultimate high ground has no ground. The satellites in orbit around our planet provide the critical infrastructure we use to defend and protect the security and prosperity of this world we all share. But space is no longer a benign environment. Adversaries and near-peer nations are actively working to dominate the most critical battleground of our day. At Space Systems Command, the time to act is now. The race is on.
Our adversary is out there. They are going to work every day trying to work harder, smarter, faster than us, but we are making sure that that does not happen.
The Guardians, airmen, and partners of Space Systems Command are working with unstoppable urgency to innovate and act now, delivering solutions to emerging threats, creating resilient space architectures we can all rely on, especially during times of crisis and conflict.
The fight could happen tonight, it could happen tomorrow, it could happen in a couple of years, but we need to start innovating now, and that's exactly what we're doing.
For Space Systems Command, working faster means breaking from the status quo, exploiting existing space architectures and capabilities in creative new ways, working with commercial industry, innovators and tech startups, and allied nations to exploit, buy, and build, to deliver better, faster, and more affordably.
We are advancing the space architecture that we have up there right now, making sure that it's optimal, making sure that we get new space architecture set up, prototyping, experiments, to ensure that we can outpace the enemy tomorrow.
To maintain our lead in space, Space Systems Command has embraced a new culture, empowering its people to race forward, speak up, and connect with industry in unprecedented new ways.
Our people are agile, they continue our partnerships, they are working collaboratively day after day in order to contribute to the big warfighter purpose.
Space is a team sport. We have to work together to provide integrated, resilient capability and speed in order to fight through any contingency and crisis.
Space Systems Command is moving fast to maintain U.S. superiority in space, running a marathon of sprints, thinking differently, acting boldly, empowering at every level to make space work for us all. At Space Systems Command, space starts here.
At T-minus 4 minutes and 45 seconds, all systems are currently a go for an on-time liftoff. Next up, the trusted structure next to the vehicle, which is known as the strong back, will begin to retract away from the vehicle, and that is in preparation for liftoff.
The strong back retract has started.
And there's that call out. Now, you could see on your screen, just below the fairing, around the second stage are some clamp arms, and they're starting to slowly open up. Once they are fully open, then the TE can begin to recline away from the vehicle. And the vehicle is nearly fully loaded with propellants and will complete at T-minus 2 minutes. And there you can see on your screen, those clamp arms are opening up there. The range is green and ready to support. Weather is 90% go for T0. So
N1 lock float is complete.
Very great news with the weather. If for some reason we do not launch today, we do have a backup opportunity tomorrow around the same time. And there you can see on your screen, the clamp arms are now fully open. So that TE to the right of the vehicle that you see there, to the right of the fairing, is beginning to slowly move away from the vehicle. Additionally,
PY lock float is complete.
Additionally, it is worth noting that at the request of our customer, we will, again, not be showing views of the payload. So we will be ending the webcast just after Falcon Heavy's side boosters make their way back to land on landing zone 1 and landing zone 2 around the T+8 minute mark into flight.
Center core lock float is complete.
And we just heard that call out.
Spacecraft is on internal power.
Just heard that call out that the center core liquid oxygen loading is complete. That concludes all first stage vehicle propellant loading. We are still loading liquid oxygen on the second stage, and that should conclude at the T-minus 2 minute mark, which will also conclude all propellant loading for Falcon Heavy. And you can also see these white clouds on your screen. This is normal. This is us just venting out the boiled off liquid oxygen at the liquid.
Stage 2 lock float is complete.
And there's that call out that stage 2 LOX load is complete. That concludes propellant loading on Falcon Heavy. Again, those white clouds that you see around the vehicle are normal. That's us venting out the liquid oxygen that has boiled off of the liquid surface out into the ambient air. Once that cold liquid oxygen meets that warm ambient air, it basically condenses just as you would see water condensing around a cold glass of water. The next event coming up will be Falcon Heavy in startup. That's at the T-minus 1 minute mark.
Ground gas closeouts.
And now that we have finished the propellant loading, we are also clearing out the liquid oxygen line on that transporter erector, and that's why you see a little bit more of those white clouds there on your screen. Again, at the T-minus 1 minute mark, Falcon Heavy will be in startup. This is an autonomous vehicle, so the internal flight computers will take over the launch countdown.
Falcon Heavy is in startup.
Great news. There's that call out. That Falcon Heavy is in startup. Now just waiting for the final call from the launch director.
This is the mission director. Go for launch.
And great news with that call out. All systems are go for launch of Falcon Heavy with USSF 52.
T-minus 30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power and liftoff of Falcon Heavy. Go USSF 52. Pushing downrange. M1D chamber pressure nominal.
Nominal power and telemetry.
At T plus 50 seconds into Falcon Heavy's flight, under the power of 5 million pounds of thrust, Falcon Heavy is carrying OTV-7 out to space. And we are coming up on max Q here in a few seconds.
Max Q.
And great call out there. We have passed through max Q. That is the point of peak mechanical stress on the vehicle, and we've now passed through that. So we do have a few events coming up here. That will be booster engine cutoff, or BECO, separation of the side boosters, followed by side booster boost back burn startup, and then the center core main engine cutoff, or MECO. Now, again, those are a few events coming up here. BECO, side booster separation. That'll be the separation from the center core. The center core will continue to carry stage 2 with the payload until it shuts down its engines with MECO and performs a standard stage separation like you see on a Falcon 9. And there you can see on your screen, on your right-hand screen, some views from the side boosters and a really awesome view of Falcon Heavy on your left-hand screen, with all of those engines burning really bright there. Coming up on BECO in a few seconds here.
Booster engine cutoff.
Side booster separation confirmed.
And back to.
Booster boost back startup.
And great news, we were able to also see that live on your screen. BECO, the side boosters have separated from the center core, and we have the startup of the boost back burn on both of those side boosters, looking really awesome there on your screen.